Hi. So as we know, recently the 2022 AMC 10A happened, and here's problem 19. Define L sub n as the least common multiple of all the integers from 1 to n inclusive. There's a unique integer h such that 1 over 1 plus 1 over 2 plus 1 over 3 up until 1 over 17 equals h over L of 17. What is the remainder when h is divided by 17? So let's start this problem by finding the LCM of the integers from 1 through 17. So we write down the integers from 1 through 17. And this is the LCM because when we divide by 16, all the factors of 2, all the factors of 2 from these numbers go away, and that leaves the other numbers. Because 16 is the greatest power less 17, when we divide by 16, all of the numbers that have 2 as a factor will be erased. And when we do the same with 3 squared, because 2 is the least power of 3 less than 17, it's the greatest power of 3 less than 17, that leaves us with only the factors of 5, 7, 11, 13, and 17. They all have maximum powers of 1 because their squares are all greater than 17. So this is the LCM. Next, we take this expression 1 over 1 plus 1 over 2 plus 1 over 3 until 1 over 17. We multiply the numerator and the denominator to make the denominator L of 17. So the denominator for the first term, it's L of 17 over 1 times 1 because that's L of 17. For the second term, it's 2 times L of 17 over 2, because that gives L of 17. And the numerators will also have to be multiplied by the same value to make an equivalent fraction. So the denominator will be L of 17 for all of them. And now we can just add the numerators to get h. So hence, h is the sum of all the numerators of these terms. So it's L of 17 over 1 plus L of 17 over 2 plus L of 17 over 3 plus L of 17 over 4 and L of 17 over 5, L of 17 over 6, L of 17 over 7, and L of 17 over 8, all the way until L of 17 over 17. So now h, when we divide each of the terms by 17 to find the remainder it leaves, all the terms less than 17 will be divisible by 17, because L of 17 in itself is a multiple of 17. And if we divide it by any number other than 17, because 17 is prime, it's also going to leave a remainder of 0 when you divide by 17. L of 17 over 3, for example, leaves a remainder of 0 because if we take this L of 17 value and divide by 3, the exponent of 3 goes down to 1, but the 17 exponent remains unchanged. So all of these terms, except for L of 17 over 17, will leave a remainder of 0 when you divide by 17. So we can write h to be congruent to L of 17 over 17 mod 17, which basically means that it leaves a remainder of L of 17 over 17 when you divide by 17. So now we can write L of 17 as 2 to the power 4 times 3 squared times 5 times 7 times 11 times 13, because when you take L of 17 and divide by 17, the 17s cancel out and you're left with this expression. So we can expand these to write 16 times 9 times 5 times 7 times 11 times 13. There's a rule with remainders. If you divide by 17, if they're being multiplied or added, or any of the other operations, then you can divide by 17 and take the remainder, divide each term by 17, take the remainder, and in this case, multiply them all. So for example, when you divide by 17, 16 leaves a remainder of negative 1, dividing by 17. 9 leaves a remainder of negative 8. 5 leaves a remainder of 5, 7 leaves a remainder of 7, 11 leaves a remainder of negative 6, and 13 leaves a remainder of negative 4 when you divide by 17. So now let's focus on 5 times 7. 5 times 7 is 35, and using our rule, 35 divided by 17 leaves a remainder of 1. So you can just, if we want to find the remainder when you divide by 17, we can just replace this 5 times 7 with 1. And now we can focus on negative 6 times negative 4, which is 24. Dividing by 17 leaves a remainder of 7. Negative 1 times 8 is 8, and that leaves a remainder of 8 when you divide by 17. So we are left with 8 times 1 times 7. 8 times 1 times 7 is 56. And 56 leaves a remainder of 5 when you divide by 17. So our final answer is 5, or C.